Hello, today I'm going to show you how to make solutions that we would use in our molarity and absorbance lab. We're not going to take any data at the end with the spectrometers because I'm going to be sending each lab group their own data that has some built-in errors, and we've already seen how spectrometers work. So for the purposes of this lab, I just want to show you how we would make up solutions. Now you were supposed to do for pre-lab question 1A, question 2A, and question 3B to find out the concentrations of those solutions. If you haven't done those, please make sure you do those before you hand in the labs. For 1A, you should have found that you needed 6.24 grams of the copper sulfate pentahydrate to make up 0.50 molar of 50 milliliters of that solution. So I'm going to measure out 6.24 grams of the copper 2 sulfate. You should recognize this. This was the same copper 2 sulfate that we used in our stoichiometry lab way back at the beginning of the year. So 6.24, what I'm looking for. Almost there. Just a little more. There we go, 6.24 grams on the dot. And I'm going to take that, I'm going to put it into this 50 milliliter volumetric flask. Use this little funnel to get it all in. Now, it does sometimes take a little while to get it in. Oh, that was nice. And I have to make sure to get the residue off of the weighing boat because this counted in the mass and this will count towards the molarity of the solution. This is deionized water I'm using so that there's no contamination. And see deionized water here. And as we discussed in class, when making up these solutions, we're going to fill up the bottom part of the volumetric flask to about 3/4 of the way full. And then we're going to put the cap on it and we're going to shake it up to get the copper 2 sulfate dissolved. This does take a little while, so give me a moment. If we didn't have the space, this agitation would not be as effective. That's why you need to leave the space above the level of the liquid. And you'll notice I keep my finger over the stopper so that it doesn't fly off. There, just a little bit more. And you see, if you were doing this in lab, you'd be chit-chatting with each other as this was going on. Hope everybody's doing okay. Once this is dissolved, then the rest of the procedure is a lot easier. Not quite there. A couple of stubborn crystals in there. Of course, we recognize that blue copper 2+ solution. We've been seeing that all throughout the year. I'm going to go ahead and fill this up with water now. I'm going to use the squirt bottle to get up into the neck of the volumetric flask. Now I've done this a lot, so I'm going to be able to stop at the right point. And then I'm going to use the little pipette to fill up to the line. Now I don't know if you can see the line from there, but I'm going to be getting it right up to the line. And then I'm going to stopper it, and to mix it now, since the agitation wouldn't work as effectively, I'm going to invert it several times like this until it is completely mixed. I'm going to check one more time to make sure that the level of the water is at the level of the line, and it looks like it is. If it wasn't, I would add a little bit more. I would top it up with a little bit more water, a drop or two of water from the pipette. So now we've got our 0.5 molar standard solution. This is what we're going to use to make the rest of the solutions. Since we've got it already made up, I can pour it into this beaker without changing the concentration, and now it's available for me to do further dilutions. At this point, we'd also take a bit of this solution and put it into the spectrometer to measure its absorbance. We'll talk more about that in class, how that works and why we're measuring the absorbance and how we use that to understand the concentration of the solution. Next, in number 2, you should have found that you needed 17.5 milliliters of the 0.5 molar copper 2 sulfate in order to make 25 milliliters of 0.35 molar solution. In order to get the right amount, we're going to use this. It's a graduated pipette. So this is a pipette, but it doesn't measure things accurately. This measures things accurately and precisely. You can see along the side the markings. Those are 1 milliliter markings graduated in 0.1 milliliters. So I can measure very precisely the volume of the solution that I'm going to be pulling into the pipette and how much I'm going to be putting out of the pipette. I'll talk about that as we're doing it. This green device is a pipette filler or pipette pump, and the way it works is I put the pipette into the solution and I use my thumb to rotate the thumb screw, and thinking about our gases unit, we're creating a low pressure region up above, and the atmosphere is pushing the liquid up into the pipette. Now I want to get down to eye level to get to my 0 mark, because at 0 now I have exactly 10 milliliters of the copper 2 sulfate solution in here. And in order to get this into the next volumetric flask, I release the valve over here and I let it drain into the volumetric flask. A little bit of water, a little bit of solution at the bottom, I don't care about. On the side of this, all devices have either a TD or a TC designation. This TD means to deliver, which means that as I let it drain, the amount of liquid that drains is exactly how much liquid I have measured. At this point, you realize that I need another 7.5 milliliters, so I'm going to get that 7.5 milliliters into the pipette. And I'm going to transfer that to the volumetric flask. Let's put that down for a moment. Now, one of the mistakes a lot of people make is thinking that at this point they're done, but we haven't added any more solvent. So if we haven't added any more solvent, the concentration in here is still the same as the concentration in here. So let's go ahead and add some water. Notice this is not as complicated or complex a process because we already started with the solvent dissolved, so we didn't have to shake it up. We can go straight to the final step of diluting it to the calibration mark. We do have to do the same inverting, like so. And now we have our 25 milliliters of 0.35 molar solution. Again, at this point, you would put some of that into a cuvette and measure the absorbance, and we will be plotting those up. In part three, we are going to use a quicker, not quite as precise measurement, because we're going to assume that the volumes are additive. In these cases, we didn't assume that the volumes of the two liquids that we put together are additive. This is a pretty good assumption as long as the concentrations are relatively dilute. And so what I'm going to do, I've got 4 test tubes lined up here, conveniently labeled 1, 2, 3, and 4 to match the test tubes that we have there. In test tube number 1, I'm going to put 2 milliliters of my copper 2 sulfate solution. Again, I'm just draining. Notice I'm not pushing down on the plunger. In test tube number 2, I'm going to put 4 milliliters. Now this pipette is labeled from 0 down to 9, 10 presumably being the bottom, which means I'm actually doing a little subtraction. In order to get 6 milliliters, I need to come up to the 4 milliliter mark. And finally, 8 milliliters of the 0.5 molar copper 2 sulfate solution. Okay, again, these solutions are not diluted yet, so I'm going to take my deionized water. I could quickly clean out that pipette, but in the interest of time, I'm going to switch over to a clean pipette and use this to pipette out the water. And I'm going to go in reverse direction, 2 milliliters of water in the last 4 milliliters of water in number 3. Now the levels of the liquid might be slightly different. That's because the test tubes are a little non-uniform. They don't have exactly the same diameter. 6 milliliters of water in test tube number 2. And finally, 8 milliliters of water. In test tube number 1. As I said, if this was the actual lab, you would then take each one of those solutions and put them into a cuvette to measure the absorbance. But for now, what I want you to do, I'm going to bring the camera closer, excuse me, and we're going to just take a look to demonstrate. Hello, Mrs. Bailey. To demonstrate that as you go more and more concentrated from left to right, I hope you can see that the solutions are getting darker and making it more obvious that there is a more concentrated solution in there. All right, so that's the making of the solutions, and we'll talk about how to work up the lab in class.